Lol, so let's continue with the sigmoid function, but this time with two features now. So of course we will get a 3D plot now because we have x1, x2, and then we have corresponding y as the output. Correct? With for fixed w and b. So w and or here it will be w1, w2, and b, but those will be fixed parameters. Correct? So those are not independent variables. That's what my concern is here, that you don't confuse it with independent variables and w and b's. So now let's see that what I mean. So I just wrote the same function but with one more feature now, and I just replicated it in Python, which is just np.exp and w1 x1 plus w2 x2 plus b. And if we will just give this just to check if our function works or not, it's giving some value, right? So if you can check this random values by giving any random values, we know that if w1, w2, and b are 0, we should get 0.5, and we are getting, okay. So for the function looks correct. But now the main concern is, as I explained, sorry, that the main concern now is that we need a grid, right? So but why we need a grid? Let me try to explain that here now we know that we need to have this x1, x2, and y. Correct? This is x2 and y. So now for any point, let's say x1 and x2 here, we need a corresponding output on a 3D surface or y coordinate z axis right here. And for such range of values of x1 and x2, we need to plot some surface. So it will be a 3D plot or a surface, right? So we'll see how this surface looks like. And for that purpose, we need to have a 3D plot, and we need to have a grid, a grid of all the values of x1 and x2, or a pair, right? x1, x2, like such pairs in the range of x1 and x2, right? So for that purpose, what we will do, again, we'll generate 100 points. Okay, we are taking 100 because it's good to visualize if you have more number of points. And now in order to generate a grid, right, we are going to use something called as numpy.meshGrid function. I have explained this function before as well in one of my videos, but it's been a while since I uploaded that, so I'll explain that in this video as well. So don't worry, you don't have to go to that video again. So what function we are going to use, let's see, np.meshGrid, and the arguments will be of course x1 and x2, and what it will give is two metrics or two numpy arrays, and let's name them x, and we have to name because they are two, so let's say first one, and let's name it as second one. Now let's try to see the shape of them. So let me print the shape xx1 dot shape, and similarly xx2 dot shape. And we are getting 100, 100. Now you might be wondering, so again, if I'll go there where I plotted this thing, so you might be wondering, if my this has 100 points and this has 100 points, then for each point, right, we will get some pair. So in total we will get 100 cross 100, so we will get 10 raised to 4 pairs. But why this numpy.meshGrid function has two numpy arrays, each of the shape 10 raised to 4, right? 100 cross 100, or how total we have 10 raised to 4 points here as well, and 10 raised to 4 elements here as well. Why? So for this purpose, we have to understand numpy.meshGrid function, and let's go there now. So I'm using this Java T-Point website, which I used in my previous video as well. So pardon for this advertisements. So we need such a grid, right? And for such a grid, here we are using numpy.meshGrid. So let's see now why we are getting 100 cross 100, but let's take just a different example. So it's this more or less the same thing, but just smaller example. Rather than 100 points, I'm just taking a really small example. So again, it's the same thing. Numpy. We are using line space. So what this will do is it will generate a value between 1 and 2. Okay, over here we use minus 10 and 10. But how many we need? NA is 5. So it will generate 5 values, and it should be equidistant. So for that, we will need to divide it perfectly. So it will be 1.25, 1.5, 1.75, and 2. And that's what we are getting here. You can see. Just ignore the rest of the things as of now, but we are getting something like this. And for B, So this is just for A and B. Okay, this is just, these are the outputs, not A and B. Just I'm writing what A and B looks like. And for B, it should be a range between 1 and 2 again, but there should be 3 points in total. So in to equidivide, it should be 1.5 in between. Okay, so we are getting, you can see here 1.52, but it's repeating. Why it's repeating, we'll see, because it's the inbuilt functionality of this numpy.meshgrid. Okay, so now let's see why we are getting, when we just put A and B into this numpy.meshgrid function, we are getting some output xa and xb, and if we print this, we are getting something like this. Let's see now we are getting, why we are getting this. So for that purpose, I'll just write A and B again. You will quickly realize why I'm writing it again, but let me just rewrite it in 2, and here we are getting 1, 1.5 and 2. Okay, so now let me just write, this point will be 1 comma 1, this will be 1.25 comma 1, this will be 1.5 comma 1. Okay, I'm just writing, this is x-axis, this is our y-axis, that's it. Okay, this will be 1.75 comma 1, and this will be 2 comma 1. Then this point will be 1 comma 1.5. So I'm writing just like this, x comma y in general. So x coordinate should be first. Then 1.25 comma 1.5, then 1.5 comma 1.5, then 1.75 comma 1.5, and it will be 2 comma 1.5, and so on for the third one. So if you will notice something, that just focus on the x coordinate, 1, 1.25, 1.5, 1.75, and 2. This is what it's written here, isn't it? Now if you go down, it's again 1, 1.25. It's repeating the same thing, and that's why it's repeating the same thing here. So now you know what this mesh grid function do. And the same for the last thing, right? It's repeat the same thing again. So it's repeating the same thing again. And if you will see the y coordinate now. So if you will see the y coordinate here, 1, 1, 1, 1, and 1. And this you can see 1, 1, 1, 1, and 1. Then 1.5, 1.5. So you can see 1.5. And then last we have not written, but it's 2, 2, 2, 2, 2, right? And that's why we are getting, so here we will get 3 comma 5, right? Here we will get 3 comma 5, correct? Because we have 3 points and 5 points, right? In A and B's. So that's why we are getting 100 comma 100, but two things, like two ND arrays or numpy arrays of x11, xx1 that we called, and xx2 of each of 100 comma 100, correct? So you know why we are getting this. Okay, but we can also get 5 comma 3 as well, and for that purpose, this is just for information purpose, which I explained in my last video as well, which is this indexing. So by default we are having a Cartesian coordinate indexing, that is x comma y, but we can also have the matrix indexing, and in that case our output will be totally inverted. That is, if we are getting 5 comma 3, we'll get 3 comma 5, and vice versa, correct? So let's see what I mean by this. So let's have this again. So what I mean by this is nothing but, let me just write it here. Let's say this is my matrix and this is my rows. We know this is first row, second row, third row. Usually it starts from 0, but I'm writing for simplicity. And this is column, first, second, and third, and so on. So this point will be first row, first column. This point will be second row, first column, and this point will be third row, first column. So you can see that in Cartesian coordinate system, if I just parallelly draw it here, this is x, this is y. What this will be? This will be, let's say, first point, this first 1 comma 2, right? But here it's 2 comma 1. So the rows are here indicating the y-axis, correct? Whereas here it's the horizontal thing. That is, we are writing first as horizontal, right? First coordinate. But here we are writing first coordinate as our vertical. correct? Because in matrix it's like row comma column, I comma j. I first is row and second is column, and that's why these two things are vice versa. So if you get 5 comma 3 in this case, you can 3 comma 5, you can see 3 rows 5 columns. Then if you just provide this argument that index equals to ij, you will get 5 comma 3 for both. Okay, so that's the only thing that we have to see. Now let's go back. So this is just this indexing that I explained. So you just have to write matrix ij, that is indexing ij, and it will be perfectly fine. So here they have also showed this thing, I think, or I don't know, they haven't shown the use of it, that how to use the matrix index. But yeah, we are going to use this to plot our 3D plot. So let's go there now. So let's continue from this point that for fixed values of W1, so let's just fix those. Sorry, let's fix W1 as 1. I'm just doing any random values, okay? So don't mind. Let's say it's 4, and let's say B is 0, just for time being. And now let's give our output Y, and let's assign our sigmoid function all the arguments that's needed. Sigmoid 2D, we have to give in the same, so it should be same order, xx1, xx2. Again, it will, here we have just defined for scalar, but it will do the broadcasting. This multiplication will be broadcasted in Python automatically, as we have seen in our previous video. So W1, W2, and P. Okay, so we have everything, and let's hit. So yeah, we are getting perfectly without any error. Now let's try to plot this, that how this looks like. Correct? We have, because we have to plot, and we know that we can't use our plt.plot, because if we just use our plt.plot, it's not good. Okay, we'll get some error because it just has two arguments, x and y, but here we have x1, x2, and y, and we can't give x1, x2 here, and that's why we need to use something else. Correct? So let's see what we will use. So firstly, I will generate the handler for the figure. Okay, this is also easy. So it's just the figure. It's just initializing that I am trying to plot an object, something called as figure. And this will be having the axis of my figure. Let's name them 3D. So these are all really simple things you will get to know with practice. It's nothing rocket science in here. And what we have to do is, we have to do this ax.plot surface, because we have to plot surface now. And in surface, now we can give 3 arguments, x1, x2, and whatever y we have got. Correct? And let's run this, how it looks. Yeah, you can see we are getting something really nice. If you will look from this side, you will see that we are getting similar to this, but in 3D, right? This is just a side view, okay, of this 3D plot. Correct? Now let's colorize it a bit and also label it nicely, because we have to label, we should know that what this axis, all this axis means. Correct? So let's label it ax.set label, set x label, I guess. Yes, it's set x label, and we'll just give some name, which are our features, capital X1. Correct? Now let's just copy this 2 times, and we'll rename it to, x2, and this should be just y. Correct? And also there is something in the handler of the figure, that how we like to view it. So view initializer, and this should be the angle, that from which angle you have to view. So let's say we have to view from 30,200 angle randomly. I'm just saying, yeah, you can see the angle changed. Correct? So you can play with this viewing angle, but it's not that important. And also, like here, we are not able to figure out what is the value of y. So let's colorize it a bit. So there is something called as, in the plot surface, there is something called as color map, and let's call it, if we'll call it just binary, then it will be black and white. Okay, so you see, so black indicates 1 and white indicates 0. But we are not dealing with just perceptron now. We are having some probabilistic value which is ranging from 0 to 1. So it will be nice if we can colorize gradually. And for that, there is something called as, I don't know how to spell this, but this is where it is. And if we'll see now this thing, you can see that yellow, it's gradually. So the purplish, then it's become greenish, and then it's slowly, gradually becoming yellowish. Correct? And now we have our labels as well. Why we are, we all have our X labels. Pardon. This should be Y and this should be Z. Correct? So now you can see perfectly X1, X2 and Y, and we are getting some plot, which is perfectly correct. Okay. So that's how our plot should look like. And I hope you realize that why this plt.plot was not useful. If you'll just do this, it will give some error. So that's all for this video. I hope this was interesting, and especially the numpy.meshgrid function. Stay tuned, keep learning, and we'll see each other soon. Thank you.